Hey guys, in this lesson we're going to take a look at shapes and showing whether or not they are similar, and if they are similar, making the similarity statement, and then also writing a similarity ratio. So to start off with, similar. When we talk about similar shapes in geometry, it's going to be two shapes are considered similar if you can show that they have three congruent angles, so three congruent or equal angles, and each pair of corresponding sides are proportional, or they have the same exact similarity ratio. So what that'll look like is for the angles, angle A, and what I mean by corresponding, so they have to have three sets of congruent angles and each pair of corresponding sides. So what that means is, if we take a look at angle A, it would have to be congruent to angle D. So angle A would have to be congruent to angle D. So that would be 1, and we need 3. So then looking at angle B would have to be congruent to angle E. And angle C would have to be congruent to angle F. So that's the first part you have to do. First part you have to do is show that the angles are congruent. Second thing you have to do is show the sides are proportional. And what that means is you're going to take each of the sides. So you're going to take side AB, and AB is going to match up with DF. You see how it goes AB for your angles, AB for angles, DE for your sides. So AB matches up with DE, and whatever that fraction or ratio would be, it's got to be equal to BC is going to match up with EF. So you would have BC over EF, and then that would have to be equal to AC over DF. So all three of those values would have to be exactly the same, and it'll make a lot more sense once we start doing problems that have numbers with them. And what this is called, these numbers that we got here, these fractions, they're called similarity ratio. And it's basically the fraction that is created when you compare one side of a shape, so one side here, to the shape in a corresponding side. If all of these are the same, then the shapes are going to be similar. So pretty much you could take what we said here, and that would be a really good example for down there. So then we've got the similarity statement. And the similarity statement can be used in a lot of different ways. It can be used to show that what's in the picture is congruent, and it could also be given to you without a picture, and from that similarity statement you use that to create a picture. So if we were to write a similarity statement for what's going on up there, triangle, we've got A, B, C. Whenever you pick what goes first, you just put it in whatever order you want it to go in. Is going to be similar to, and the notation for similarity, it's a tilde is what it's called, but it looks like that. So just it's a sideways S or a squiggle is going to be congruent to, and this is where it matters. So we've got angle A matches up with angle D. So D goes first. And then we've got angle B here, has to match up with angle E. And then last we have C, and C has to match up with F. So a similarity statement for that example would be triangle ABC is similar to triangle DEF. So the way you read that is similar to. So if we start trying out some examples, they want to know, are the shapes similar? And if they are similar, write the similarity statement and the similarity ratio for the shapes left to right. So that means what's on the left is in the numerator and what's on the right is in the denominator. And depending on the problem, it'll tell you what'll go where. So first thing we have to decide, are the shapes similar? Well, if we go back to our definition, in order for them to be similar, we have to show the angles really are congruent and the sides really are proportional. So we'll start off with the angles. So we'll start with angle H. So looking at angle H, it's got 2 arc marks. So we need to find an angle over here that has 2 arc marks. So that's going to be angle X. And we know that for sure they are congruent because they both have 2 arc marks. And then we can do angle I. So angle I, then we're looking over in this other triangle for where they have 1 arc mark. There's angle W, and we know they're congruent because they both have the same number of marks. And then angle J, congruent to angle, there's one with 3 here, angle Y. So we're good for angles. We know the 3 angles are congruent. Now we need to do the sides. So when we're doing the sides, we need to make sure we're comparing same thing to same thing. So looking at side HI, HI is going to match up with, it goes blue to pink, so blue to pink here is going to be XW. Another way to look if you're not using colors, HI here is going to match up with XW there. So the value for HI is 30 over the value for XW is 20. So 30 over 20, if you simplify it, is going to be 3/2, and you're going to want to leave it as a fraction. So there's those. Now looking at the next set of sides, we've got HJ. So HJ compares to XY, and HJ has a value of 24 over XY has a value of 16, so we're doing these there. And if you simplify, 24 over 16 is going to simplify down to 3/2. So we've got 2 out of the 3 we need. We need to check the last one. So looking at the last one, we've got JI over, and if we check here, JIYW. JI has a value of 27 over 18. So 27 over 18 also simplifies down to 3/2. So because we were able to show that all 3 angles are congruent and all 3 sides have the same similarity statement, or the same similarity ratio, we know that triangle HIJ is going to be similar to XWY. So triangle HIJ is similar to triangle XWY. So the first thing it wanted to do, it wanted us to show that the shapes are similar. We know they're similar because they have congruent angles, the same similarity ratio, so yes, they are similar. They want us to write the similarity statement. So there's the similarity statement right there. And then it wants the similarity ratio. And all 3 of those right there are the similarity ratio, but you only need 1 of them. So if we try another one. Looking at the angles, we've got, so we'll show similarity first. So we've got to go angle E. We'll do angles. Angle E is congruent to angle V. They both have one arc mark. And then B and W match. And then C and T. And then angle D is congruent to angle U. And we know these are all congruent because they have the same exact arc marks. Now, just because all the angles are congruent doesn't mean you have two similar shapes. You have to check the sides. So for matching up, we're going side EB, and I'm just getting sides, and I'm getting it from the picture. So EB matches up with VW. EB has a value of 8 over VW has a value of 20, and 8 over 20 will simplify down to 2/5. So trying the next one, BC. BC is going to match up with WT. BC has a value of 4 over 10. 4 over 10 will simplify to 2/5. Next, we're looking at CD. CD over TU. CD has a value of 8 over 20, and we know 8 over 20 simplifies down to 2/5. To check the last one, the last side we have to do is ED over ED matches up with VU. ED has a value of 10 over 25, and 10 over 25 simplifies down to 2/5. So because all of the angles are congruent and all of those sides are proportional, they have the same similarity ratio, we have similar shapes. So are the shapes similar? Yes, they are similar. The similarity ratio is 2/5, and our similarity statement is, I'm going to do them in order, BCDE is going to be similar to BCDE is going to go WTUV. So there's our answers there. So this needs a yes up there. Well, with these, they were kind of general with the angles, and they just gave us angle marks to work with. Looking at this one, they give us actual angle measures to work with. So we're still doing the same thing. Are the shapes similar? If they are, we've got to show the angles are congruent and the sides are proportional. So looking at the angles, I've got angle Q is going to be congruent to, well, it's 56, so looking over here, there's the 56 there, and that is angle H. Looking for the next one, we've got angle P is going to be congruent to, this one is the other one that has 30, so angle F. And then last one we have to do is angle R is congruent to angle G. So our angles all check out. Now we've got to do our sides. So looking at the sides, I'll pick QR first. QR is going to match up with HG. So QR has a length of 3, HG has a length of 15. 3 over 15 simplifies down to 1/5. Next, let's do QP. QP matches up with HF. QP has a value of 6 over H to F has a value of 30. And 6 over 30 is going to simplify down to 1/5. And then last side, we've got RP over RP is going to match up with GF. RP has a value of 5 over 25, and 5 over 25 will simplify down to 1/5. So the angles are all congruent, the sides are all proportional. So yes, they are similar. Our similarity statement is triangle QPR is going to be similar to triangle HFG, and their similarity ratio is going to be 1/5. So trying out some more. Looking at this one, we haven't gotten to the point where we've talked about our rules for quadrilaterals, but what I will tell you is that those two angles should add up to be 180 degrees. So when they give you shapes like this, you've got to check. If they say these two are congruent and they don't give you values and those two are 125, and if they are congruent, using our definition for similarity, that definition says you have 3 sets of congruent angles. So that means 125 could go here, and 125 could go there, and 48 would go there, and 48 would go there. So if we check 48 plus 125 adds up to be 173, and that's not 180 degrees. So these are not similar because of that. And if you look and you check the sides 8 over 2, 8 over 2, 8 over 2, 8 over 2, everything looks like it's similar except for that. So this is, watch out for these. Those two need to add up to be 180. Basically what these are parallelograms, and so this is the transversal, and that side should be parallel to that side. So these two angles, that angle right there with that angle right there, they're same side interior. And if you remember those rules, same side interior angles are supplementary. So that's one way you could remember that. So they're not similar. So there's no similarity statement to write, and there's no similarity ratio. So moving on to the next one. So if we start comparing angles for this one, we've got angle H is 34 degrees and would have to match up in this triangle to an angle that has 34 degrees. Well, there's 35, there's 86, there's 59, and it's not a matter of close, it's a matter of it's got to be exactly the same. So there's nothing that matches up with the 34, so these triangles are not similar. And again, you've got to watch and focus on the angles in addition to the sides, because if you try out the sides, I bet you the sides are proportional. But by looking at the angles, we know they're not similar. And looking at the last example, we've got two quadrilaterals and they want to know similar. If they are, write a similarity statement and our similarity ratio. So first we've got to show the 3 angles are congruent, and then the 3 sides are proportional, or the 4 sides, 4 angles. That would work good if we had a triangle, but these are quadrilaterals. So to start off, I've got angle S. So angle S, and I'm going to look at it, and with these, some of them, they start rotating them all around different directions, and you're thinking of it as a rotation. So if we were to take this shape and rotate it this way, that would give us angle X. And if we check, those both have the 1 arc mark, so we know they're congruent. So angle S is congruent to angle X, and then angle R is congruent to angle W. And if you watch, I'm being very careful to, for the stuff that's being written on the left, I write it on the left. For the stuff that's in the picture on the right, I'm writing it on the right. And you can't mix and match between angles and sides on these shapes. What's on the left needs to stay on the left, and what's on the right needs to stay on the right, or else you'll start making mistakes. So then we've got angle Q is going to match up with angle V. They both have 2 arc marks, so we know they are congruent. And then angle P is going to be congruent to, or should be congruent to, angle Y. So there we are. We've got all angles are congruent, so we're doing okay so far. And now we need to start matching up those sides. So let's start with PS. PS, according to the angles, is going to match up with YX. So PS has a length of 26 over YX has a length of 26. So 26 over 26 is going to simplify down to 1. So trying our next side, we've got SR, and according to our angles, SR is going to match up with XW. So SR has a value of 35 over XW, there's XW, over 45. And if we simplify 35 over 45, we get 7/9. And if you look, these are not the same. So the similarity ratio are not the same. So the shapes are not similar. So that's the answer for this one, not similar. But just in case, to do the rest of the sides, next we would do QR. QR would match up with VW. QR has a value of 26. VW has a value of 26. 26 over 26 is 1. And then the last one, we've got PQ. PQ is going to match up with YV. So PQ has a value of 24 over YV is 33. 24 over 33 simplifies down to 8 over 11. So even though these two are the same, that's not enough for them to be similar, because if you remember back to our definition of similarity, each and all pairs of corresponding sides have to be proportional. So they aren't all proportional, so those are not similar. So that this page gives you some good examples of how things are not similar. This page gives you a lot of good examples on how things are similar and all the things that you would need to show. If you have any questions, be sure to write them down and ask when you get to class.